Science Journal for Kids and Teens presents What are good ways to track melting glaciers? Read by Miranda Wilson. Abstract. Have you ever watched an ice cube melt on a hot day? Well, that's happening to glaciers all over the world. Glaciers have important impacts on water resources, runoff, and sea level rise. Keeping track of how glaciers change is important to predict and plan for these downstream impacts. We wanted to create a more recent record of how glaciers have changed from 2000 to 2023, so we compared and combined data about glaciers collected using different methods. We found that glaciers worldwide lost about 5% of their mass in this period. In different regions, glaciers lost between 2% and 39% of their mass. We saw slight differences between data collection methods that could add up over time. We expect glacier loss to continue, which will lead to some regions losing their glaciers by 2100. It's important to use the most accurate and up-to-date information to make predictions about glacier loss in the future. Introduction. Only 2.5% of water on Earth is freshwater, and about 69% of that freshwater is stored in glaciers and the two continental ice sheets in Greenland and Antarctica. Climate change is melting glaciers around the world. It can mess up people's access to freshwater resources for drinking and watering crops. Plus, melting glaciers have been responsible for about 20% of sea level rise in the last 20 years. This can cause flooding. It is important to measure changes in glaciers accurately and precisely. That way, we can predict and manage the impacts of glaciers melting. There are four main ways scientists measure changes in glaciers. 1. Direct observations happen when scientists visit glaciers to measure changes in the height of ice at specific points. They also measure how packed the snow is on glaciers. This can help scientists estimate changes in glacier mass. 2. Scientists can map the elevation of entire glaciers using satellites. Then, they can compare multiple measurements from different times to identify how the glacier elevation changed over time. This is called digital elevation model differencing. 3. Altimetry is similar to digital elevation model differencing, but satellites measure elevation along a line or band. And 4. Gravimetry uses distance measures between pairs of satellites to figure out slight changes in gravity. As the mass of a glacier changes, it impacts the gravitational field. These four methods differ in how often measurements can be made. They also differ in how much of the glacier they can measure. These things make it hard to compare the results from the different methods. We wanted to compare the different methods for measuring glaciers. We also wanted to figure out a way to combine data from the different methods. This could help us better compare glaciers and their changes. It would also allow us to look at changes in glaciers at regional and global scales. Here in Figure 1, you can see three of the four main ways scientists measure how glaciers change. On the left is direct observations. The image shows a glacier. The X indicates the location that measurements are made. Within the magnifying glass, you can see a person next to a measuring device. The middle image shows digital elevation model differencing. The image again shows a glacier, but this time with rectangles indicating where measurements are made over the entire area. In the sky, you can see two satellites that are taking the measurements. The image on the right shows altimetry. In this image, you can see a satellite measuring the glacier along a track or band. Methods. We collected 233 quality data sets about changes in glacier mass. The data sets are from all the regions with glaciers around the world. They have data about glacier mass changes between 2000 and 2023. We divided the data sets into groups by region. We also divided them by measurement method, and we combined them into a best estimate. Then, we used the data in three ways. We compared changes in glacier mass between measurement methods. We also compared changes in glacier mass among regions. And we estimated global changes in glacier mass. Results. We found that the four ways to measure glaciers were similar, but each method gave us slightly different results that could add up over time. We found that glaciers in all 19 regions lost ice from 2000 to 2023. We saw that glaciers from individual regions lost between 2% and 39% of their ice. Regions with less glacier coverage lost a larger percentage of their ice. For example, Central Europe and New Zealand lost 39% and 29% of their ice. In contrast, regions with larger glacier coverage, such as Alaska, lost a smaller percentage of their ice. Glaciers across the world lost about 5% of their total ice between 2000 and 2023. This represents 18 millimeters of sea level rise. That is 273 gigatons, or billion tons, of ice and 0.75 millimeters of sea level rise each year. That's 3 Olympic-sized swimming pools of meltwater every second. We also saw that ice loss was 36% greater between 2012 and 2023 than it was between 2000 and 2011. Here in Figure 2, you can see the percent of glacier mass lost between 2000 and 2023 for several representative regions. The figure shows a world map. Each of the 19 regions can be found in a grayed box. The locations of the glaciers can be seen in dark blue. Starting from the bottom left and traveling clockwise, you can see the southern Andes lost 12.8% of its glacier mass, Alaska 8.8%, Arctic Canada North 3%, Central Europe lost 38.7%, the Russian Arctic 3.2%, Central Asia 8.5%, and New Zealand lost 29.3% of its glacier mass. In the middle of the figure is a pie chart showing global glacier mass lost at 5.4%. Which region in the figure had the largest percentage of glacier mass loss? Which had the smallest? Discussion. We were not surprised to find that glaciers around the world are melting. Our results agree with earlier global estimates, but we found that the way scientists measure glaciers makes a difference. This is especially true at a regional scale. Scientists need to know the strengths and limits of their measurements. For example, digital elevation model differencing is good at showing long-term trends for glaciers all over the world. It is not great at showing the differences between years. In contrast, direct observations can provide detailed data, but only from individual glaciers. We created a more recent and accurate record to compare changes in glaciers. It includes data using all 4 measurement methods, and includes changes through 2023. Our new record also includes information from around the world. Our data could be helpful for improving public reports, for example by the IPCC, the Intergovernmental Panel on Climate Change. It will help us make plans to protect freshwater resources. It will also help us combat sea level rise and flooding in the future. Conclusion. Knowing about how climate change impacts glaciers is important. Measuring glaciers is one way to get more information, but how we measure things matters. Imagine you are trying to tell a friend how big your new paperback book is. You could say it's as big as 2 hands placed side by side and 1 finger thick, or that it's big enough to cover your teacher's face. You could say it has 300 pages. You could say it weighs 225 grams, or 8 ounces. You could say it's 203 by 130 by 16 millimeters, or 5.1 by 8 by 0.6 inches. Each of these measurement methods could help your friend understand, but they are very different. And if you want to compare book sizes with your friend, you'll need to both use the same method. It is important to know the strengths and limitations of your measurement methods. That way, you can pick the best one for the question you are asking. So, the next time you need to measure something, make sure you think about all your options. Thank you for listening to this recording. This work has been adapted from the original peer-reviewed paper in the journal Nature, published on February 19, 2025. Research conducted by Michael Semp, Jacqueline Banwart, and the Glanby team from the Department of Geography at the University of Zurich in Switzerland. Members of the Glanby team can be found at universities and institutions all over the world. See the full list of authors and their affiliations in the accompanying PDF. Please visit our website, sciencejournalforkids.org, for more free science teaching resources. Hey everyone, we're a small nonprofit and all of our resources are free. So if you like what you see, please subscribe and share.